Hello dear students, welcome to BYJU'S Exam Prep and I welcome all for this Maha Marathon series, and in today's session I'll be talking about algorithms, part 1. Hope you are all ready. Very good morning 38 Aryan Kaurav. Good morning to one and all. Very good morning Pranab Paul. Hello sir. Kaustubh Nageshwar. Hello, how are you? Good morning Saurabh Nayak. Hello. I welcome all for this particular session. Latesh Nayak, very good morning. Hello. So this is GATE 2023 CSE exam preparation and we are doing this Maha Marathon series, and today's topic is algorithms part 1. And you also have this Maha Marathon series not just for CS, my dear friends, EE, EC, IN, my dear friends. Okay. So the complete revision in 12 days. And also you can note down there is a mega workshop conducted by Abhinav Negi sir on 15th January at 12:30 p.m. Good morning sir. Good morning to one and all. I am doing fine sir. I am doing fine. You are all doing well. Hope you are all doing fine. Nice to see you all. Nice to see you all, my dear friends. And before actually starting the class or the session, let me introduce myself. Thank you, Isai Tech. Hopefully you enjoy this marathon series also. Okay. So myself, Sridhar Dhulipala, I am having 20 plus years of teaching experience and I worked in all reputed GATE institutes all over India, and I taught offline centers all over India, my dear friends. Thank you, Ashwini. And these are my expertise. I am associated with BYJU'S from past almost 2 years, and we are working on this particular project called Recorded GATE Content, first of its kind. We created visualized animated content for you. Those who wish can download BYJU'S Exam Prep app, and under this Learn with Video Lessons category, you can find all these video lectures which were recorded by me. Engineering mathematics, discrete mathematics for computer science students, algorithms, C programming and data structures for computer science students, my dear friends. Okay, hopefully you all know very well about me. So without wasting time, let me tell you what I am going to discuss under this marathon series. Okay, see, mostly it is problem solving series, but I'll be introducing kind of formula also in between. Quick review of formula also will be done in this. Okay, concept revision also will be done together with the problems. Okay, so that is the idea. See, the part 1, I mainly concentrate on these 3 areas, that is time complexity, recurrence relations, the divide and conquer design strategy. Whereas in part 2, that is on Sunday morning 10 a.m., I'll be discussing the remaining part, that is greedy algorithms, dynamic programming and graph algorithms. So this is your part 1. This is your part 1 and this is your part 2 from my side, my dear friends. Okay, stay tuned till the end so that you can answer the questions, you can understand the concept, you can revise the formula. All the important formula will be revised here, my dear friends. Right? See, the definitions I am not discussing here, but I'll directly start away with some problems. Okay? See, the session is around 2+ hours. Let us see how many questions we can complete in 2+ hours, my dear friends. Okay, it may go up to 2.5 or so. Let us see. If time permits, we'll go beyond that. Right? Now, if you observe this, Fn is big O of Gn means F is asymptotically smaller than G. F is big omega of G means F is asymptotically larger than G. and Fn is big theta of Gn is F and G are having same complexities or same runtime asymptotically. They are asymptotically equivalent. Asymptotically means, don't worry about the term, my dear friend. Asymptotically simply means long run behavior, limiting behavior for large values of n. And similarly, Fn is small o of Gn means F is asymptotically smaller than G, and Fn is small omega of G means F is asymptotically larger than G. Let us start with problems. You need to answer your question, answer the question in the chat box, sir. Once you answer, if I need to explain, I'll explain it. If most of you answered correctly, in a quick sense, I'll answer that question and move for the next question. So please answer this question. Which of the following properties satisfied by theta notation? Theta notation satisfies which of the following properties? Answer please. Please answer this. Waiting for your responses, dear friends. Which of the following properties? Okay, only transitive is satisfied by theta notation. A, B, C, D. Saubhagya Nayak. Saurabh Mishra says only B. See, we have MSQs in GATE examination. And for MSQs, very good, Kaustubh Nageshwar, super Nana. Prajwal Nijahara, very good. Yeah. See, my dear friends, reflexive satisfied because every function is big theta of itself, is asymptotically equivalent to itself. So we can say F is equivalent to F. And what about symmetric, sir? Can you say symmetric? That is, if F is big theta of Gn, can you say G is big theta of Fn? Yes, you can say. See, let us not get into discussion of other things. Let us concentrate on subject, Mr. Vivek Kumar. Maybe towards the end, we'll discuss all such things. Okay? This is not the time where we discuss marks and all. To get marks, first we need to score this. Have you answered this question? Have you answered this question? Yeah. Now, transitivity. Suppose F is asymptotically equal to G. See, it is like F is asymptotically equivalent to G means G is asymptotically equivalent to F. So, it is fine. F is asymptotically equivalent to G and G is asymptotically equivalent to H means F is asymptotically equivalent to H. So, transitivity is satisfied. See, this transpose symmetry means, see, it's actually satisfied by what? We'll try to see. For time being, I'll cancel this because I don't know how many of you remember or know this transpose symmetry property, because my next questions are based on that property. So, I'll not reveal that now. Okay. So, once I complete the remaining two questions, then I'll reveal that. What is this transpose symmetry, my dear friends? Very good. Next one, which of the following properties are satisfied by big O and big omega notations? Big O and big omega notations satisfy which of the following properties? Akshay readily answered D. Answer quickly, sir. See, these are simple things, but generally ignored. Most ignored concept is asymptotic notation, and most of the people do lot of mistakes here. Sorry, sir, all. Now let us see this. See, my dear friends, big O means asymptotically smaller or equal to. Big omega means asymptotically larger or equal to. Now, can you say that every function is asymptotically less than or equal to itself, and every function is asymptotically greater than or equal to itself? Equal to is there, no? Therefore, reflexivity is satisfied. Reflexivity is satisfied. Symmetry cannot be satisfied because if F is less than or equal to G asymptotically smaller than G, you can't say G is asymptotically smaller than F. You can't say this, sir. If it happens, it cannot be guaranteed, sir. It cannot be guaranteed. You can't guarantee this. So this fails. Symmetry will fail. Next comes transitivity. F is asymptotically smaller than G and G is asymptotically smaller than H. Then F is asymptotically smaller than H. This is satisfied. Transpose symmetry again. I know that most of you don't know this particular property. So what I do is I'll postpone this. But for time being, I'll give you the answer. D is correct answer. D is the correct answer. Right. No problem. Next question. Which of the following properties satisfied by small o and small omega notation? Small o and small omega notation. Yeah, I'll tell you transpose symmetry. Wait, Saubhagya Nayak. I told you na transpose symmetry. I'll tell you. Wait for a while. Because next question is based on that. If I reveal this, you answer this question. If you already know it, then fine. Now Prajwal Nayak Nihara says CD, very good. Kaustubh Nageshwar says C. Sauroj Mishra says only C. AC. Isai Tech says AC. Chandana Juarupu says CD. Chandana, I call her. And Pranab Paul also says CD. Very good. Most Ashwini also saying, Indian Akshay also saying CD. Very good, sir. See, it is small o notation, sir. Small o it is. Okay. Please take it as small o notation. Now look here, sir. Small o notation means, can you say that F is asymptotically smaller than F? Can you say this? This is wrong. So reflexivity is ruled out. Reflexivity is ruled out. Symmetry. If F is asymptotically smaller than G, can you say that G is asymptotically larger than F? Can you say that? Or sorry, not larger, smaller. Can you say that? No. So this is ruled out. Transitivity. Of course, if F is asymptotically smaller than G and G is asymptotically smaller than H, then F is asymptotically smaller than H. This is satisfied. This is satisfied. Now transpose symmetry also satisfied. I'll reveal that now. I'll reveal that secret now. What is transpose symmetry? I'll reveal that now. See, actually I just given for small o notation. Even for small omega notation, you can do the same thing, sir. Here, instead of asymptotically smaller, you have to use asymptotically larger notation for small omega notation. That's it. Now the suspense revealed, my dear friends. I given all the properties for quick review. For those who do not know now you know the properties and you can go back and see the properties. You can answer all the properties perfectly. Reflexivity is satisfied by big theta, big O, big omega. All big notations satisfy reflexive property. Symmetry property is only satisfied by theta notation. Theta notation is the only one which satisfies symmetry property. Then comes transitivity, satisfied by every notation. Every notation satisfies transitivity property. Now what is transpose symmetry, sir? See, this transpose symmetry is if Fn is big theta, big O of Gn, then Gn is big omega of Fn. See, if Fn is big O of Gn, then Gn is big omega of Fn. See, it is very simple, sir. If Fn is asymptotically smaller than Gn, means what, sir? Gn is asymptotically larger or equal to Fn. Gn is asymptotically larger or equal to Gn. Yeah, good morning, sir. Good morning. Right? Hope you understand. Is the idea clear? Hope you understand. And what about this Fn is small o of Gn? When you say Fn is small o of Gn means it is asymptotically smaller than Gn, then Gn is obviously asymptotically larger than Fn. This is what you call it as transpose symmetry. So we have transpose symmetry between big O and big omega. and we have transpose symmetry between small o and small omega. So transpose symmetry is satisfied by big O, big omega combinedly and small o, small omega combinedly. Because of that, in all the options, the transpose symmetry is satisfied by small o, small omega notation, big O, big omega notation. Hope you understand. Is the idea clear? Now hopefully you will not forget this. Right. Please answer this question. It's a very popular question, but very important question. Please answer this question. Next one. Very good. Very popular question it is. D, very good. Akshay Babu, Indi Akshay, why you are giving different answer? Both are correct. So you are saying both are correct means Fn should be big theta of Gn then. Both are correct means Fn should be big theta of Gn. Huh? Right, let us see this. See my dear friends, you consider Fn which is function n and Gn which is n power 1 plus sine n. See, as n approaches infinity, what is the fate of Gn? What is the fate of Gn? The fate is decided by the power. See, we know that as n approaches infinity, the sine n, you know sine n value varies between -1 to +1. So sine n varies between, actually varies means oscillates. It oscillates between -1 and +1. It is not a static value. It is not a fixed value, sir. It is an oscillating value. The value will be oscillating between -1 and +1, my dear friends. So when you add 1 to it, so 1 plus sine n value will be oscillating between 0 and what? 2. So this Gn situation will be either n power 0 to n square. So this fellow value will be oscillating between n power 0 to n square. So can you say that it is larger than Fn or smaller than Fn? What can you say here? It can't be said like that, correct? Because if it is n power 0, it is smaller than Fn. If it is n square, it is larger than Fn. It is not a fixed value, it is an oscillating value. Therefore, this particular fellows cannot be compared. See my dear friend, this is called law of trichotomy. When you have two functions, it is not necessary that they must be either like f is less than or equal to means asymptotically. F is asymptotically smaller or equal to g, or f is asymptotically equal to g, or f is asymptotically larger or equal to g. It's not necessary. There may not be any relation between two functions at all. So they are non-comparable. These two functions are non-comparable functions. So neither of them. There is no law of trichotomy. See, when you have two numbers, either a should be less than b, a equal to b, a greater than b. One of this must happen. But this is not the case for functions. This is not the case for these functions, my dear friends. So there is no law of trichotomy. No trichotomy rule. That is what we call it, my dear friends. Hope you understand. Next problem. Answer this, sir. Let us move on to the next concepts. What is the correct answer? Please answer question. Please answer this question. See, most of MSQs can be asked from this topic. There is a lot of possibility of asking MSQs from this asymptotic notation topic. Please note that point. and D. Suraj Mishra says B and D. True. Which of the following are true? I said which of the following are true? Dear. Okay. Let us see the first one, sir. Let us see the first one. Option A. Okay, D. Most of the people are going for D. First, let us see. See, first one says F is asymptotically equal to G. See, when it is asymptotically equal to G, if you want, you can say it is less than or equal to G. There is nothing wrong. If you say it is greater than or equal to G, there is nothing wrong. That is, if it is theta, you can say big O or big omega. But you cannot say small o, my dear friends. You can't say F is less than G. You can't say, so this is wrong. Option A is wrong. Hello, sir. Good evening, Tushar Sisodia. Now, when Fn is big theta of Gn, when Fn is big theta of Gn, again, as I told you now, when it is equal, you can say less than or equal to or greater than or equal to. That is, you can say it is big O or big omega, you can say, but small o or small omega, we can't say. So, A, B are ruled out. Now, when it is small o, can you say, when it is small o, can you say small omega? See, small o means what, sir? Fn is larger than G. F is larger than G. Can you say F is big omega of G? Big omega means what, sir? Sorry. I'm sorry. F is, small o means smaller than G. Can you say that Fn is greater than or equal to G? You can't say that. So, C is also ruled out. Which one is small omega? Yeah, this is small omega. Yeah, I done it. Yes. Last one, when Fn is, why to write Fn? F you write down, it is enough. When F is smaller than G, it cannot be equivalent to big theta. It cannot be equivalent, sir. Smaller means it cannot be equivalent to. Asymptotically equivalent to, it cannot be. So, correct option is only D, my dear friends. Correct option is only D. Very good. Most of the people given correct answer. Very good. So, we need to remember this. Whenever F is smaller than G, you can say that F is smaller or equal to G. And whenever F is larger than G, you can say that F is larger or equal to G, but not vice versa. Not vice versa. Not vice versa. That is, when Fn is big O, you can't say Fn is small o. But whenever Fn is small o, we can say Fn is big O. Similarly, whenever Fn is small omega, you can say big omega, but not conversely. Remember this point, my dear friend, very important. See, option D is true, Ashwini. Only D is true. It cannot be big theta, correct only. If he says it is big theta, that is wrong. If he says it is big theta, then it is wrong. He says not equal to big theta, therefore it is correct. Now, this important rule for product and addition of two functions. When you know that Fn is big O of Fn and T1 is big O of Fn and T2 is big O of Gn, the product of T1 into T2 is big O of Fn into Gn. And similarly, T1 is big O of Fn and T2 is big O of Gn. Their sum will be maximum of F and G, my dear friends. Of course, it is not only for big O, it is same true for big theta also. It is true for big omega also. If you don't remember, please note that. So, please answer this question, sir. Please answer this question. Sorry for that. You can write down later on, sir. Good morning, Nishu Kumar. Only one is correct. My dear friends, Fn Gn. Now let me find Fn into Gn. It would be n square multiplied with n power 4, n power 3, that is n power 5 plus lower order terms. Correct or not? Correct or not? And when you take Fn plus Gn, it is n cube plus lower order terms. Correct or not? So from this you can easily see Fn is of order n power 5. See, whenever it is order n power 5, you can say big theta of n power 5. You can say big O of n power 5. You can also say big omega of n power 5. So whether saying Fn into Gn big theta of n power 5 is correct or big omega of n power 5 is also correct. Product is big theta, you can say, big omega you can say. See, theta means equivalent to. Big omega means greater than or equivalent to. Yes, equal to is there, no? So no problem. So this is correct. Now Fn plus Gn is of order n cube. So you can say big theta, you can say big O, or you can say big omega. So I can say big O or big theta, all are correct. Pranab Paul says all are correct, and that is simple. All are correct. Am I clear? Now let us see the ordering of the functions. Let us play for some time. Ordering the functions. Please tell me what is the correct order of the functions. The standard problem, very basic standard problem. I started with a very basic standard. Venkat Prasanna, very good Nana, perfect, super. Three, 1, 2. Most of you are giving correct answer. Super, super, and super. See, my dear friends, the log power an is asymptotically smaller than n power b is asymptotically smaller than c power n. This is the basic idea, my dear friends. Here a and b are positive real numbers, where c is a positive real number greater than 1. AB must be positive real numbers, C must be positive real number greater than 1, then this result will be satisfied. So generally when power 10 is there, it looks bigger, but that is not the case. That is not the case. Okay, log power 10 or log power anything is always smaller, asymptotically smaller than any polynomial field. Okay, just if you remember, that is enough to say that Hn is asymptotically smaller than F is asymptotically smaller than G here, my dear friends. So the correct answer for this is option B. See, this basic ordering one should know, my dear friends. This basic ordering one should know. If you do not know, quickly note down. This is the most important ordering. Most of the questions can be answered with this ordering and little common sense. Okay? Polylog, polynomial, exponential. Log power an is asymptotically smaller than n power b is asymptotically smaller than c power n is asymptotically smaller than n factorial is asymptotically smaller than n power n is asymptotically smaller than 2 power n. This is the basic ordering you should remember. And there is something called dominance ranking, okay, which is a very common ranking which you should know. I generally ask students to remember at least this. Of course, this is common. If you know the previous rule, it is obvious, sir. From that, you can get the next ordering very easily. Constant is smaller than logarithm, which is smaller than square root of n, which is smaller than n. See here, even if you are having log power 1000 also, root n dominates log power 1000. Root n dominates log power 1000. Asymptotically. asymptotically. See, here we are talking about asymptotic behavior, means long run behavior. We are talking about long run behavior. Please remember that. Okay, and n root n square, like that. Then after that we have, after polynomial, exponential, then we have factorial. That is that. See, actually in this particular dominance ranking, in place of n, if you put log n, in place of n, if you put log n, you get log n is smaller than root log n, is smaller than log n, is smaller than log n power 3 by 2, log n square, that is log square n, log cube n, and then comes n. And this log n factorial, you have a very beautiful result. Log n factorial is big theta of n log. By Stirling's approximation, this can be proved. So log n factorial is of order n log n, my dear friends. So you can get this particular ordering just by considering the previous ordering, my dear friends. So this is what we call it as basic dominance ranking. Okay. Anyhow, you can practice this regularly. And one more very important thing is, if log fn is asymptotically smaller than log gn, only when asymptotically smaller than log gn, then you can say fn is asymptotically smaller than gn. Not always. This is a very, very important property and most misused property it is. Okay, so only when log fn is asymptotically smaller than log gn, then fn is asymptotically smaller than gn. अभी होगा मास्टर थ्योरम, अभी करेंगे. अभी शुरू तो अभी किए हैं. I always start with asymptotic notation. Yeah. Please tell me the correct ordering. Please tell me the correct ordering. Please tell me the correct ordering, my dear friends. This result you want me to repeat. For example, you have n root n and you have n factorial. Which one is larger? Mr. Prajwal Nijara, which one is larger? N root n or n factorial, which one is larger? So what you can do is you apply log on both sides. Log n root n and log n factorial. Log n root n is nothing but root n log n, whereas log n factorial is asymptotically equivalent to n log n. Now you can easily see that root n log n is smaller than n log n, which is actually root n log n is what, sir? Log of n root n, and this is log n factorial. So here what is happened? Log n root n is smaller than log n factorial. When you get this, then you can get n root n is smaller than n factorial. So that is the idea, my friends. That is the idea, my friends. Hope you understand. That is the idea. Babu, someone asked this, Mr. Prajwal Nijara. That is it. So when log fn is asymptotically smaller than log gn, then fn is asymptotically smaller than gn. Not vice versa. Not vice versa. It is vice versa. It is not true. And again, it should be increasing unbounded function. There are some more conditions for that. Please remember that. Yeah, next problem. Next problem. Yeah, we are solving this and suddenly we went back. Sorry. Yeah. Please answer. See, my dear friends, entire asymptotic notation, theta, simply consider it as equal to. Big O, consider it as less than or equal to. Big omega, consider it as greater than or equal to. Small o, consider it as less than. Small omega, consider it as greater than. That is the basic common sense. First, with that you try to solve it. If it does not work, then we need to go for some other properties. Always this is the idea. Even when you want to compare the function, first to see the basic ordering. What is the basic ordering? Polylog is smaller than polynomial is smaller than exponential. This is the basic ordering, sir. Anything will go after this. So what is the correct answer, sir? C. Wow. 4 to 4. See, how many of you identified 1 power 1.01 power 1.001 is a constant? Is it a constant or not? So it is a constant. Okay, maybe I just given a little here and there, but it is a constant fellow. It is a constant fellow. So this is a constant fellow. So that is ruled out automatically. That is ruled out automatically. That is the least fellow. So that comes second. Now next fellows you have to order. Next fellows you have to order. Now if you see n power 3 by 4, n power 7 by 4. Obviously n power 7 by 4 is larger. So we try to compare this n power 3 by 4 with n log. Very good. N power 3 by 4 with n log power 3n. And obviously n power 3 by 4 is asymptotically smaller than n log cube n. Why, sir? Because here it is power of n is smaller than 1 and here we already have power of n equal to 1. So this is smaller than n log cube n. So obviously the first one is smaller than fourth one, and you know fourth one is smaller than third one or not. For that you can just see this, sir. N log cube n and n power 7 by 4. Now this can be written as n log cube n and it is n into n power 3 by 4. Correct or not? And obviously this n and same, you have to compare these two fellows, but obviously log cube n is smaller than n power 3 by 4. So this is smaller than this. This is smaller than this. Hope you understand. So with this what happened? This n log cube n is smaller than n power 7 by 4. So fourth one is smaller than third one by 4. And second one is much smaller than all these fellows. So the correct answer is 2143, my dear friends. 2143 is the correct answer. 2143 is the correct answer. Next problem, popular question. Next problem, popular question. Babu, if I take what is C? What is C? Without knowing C, how can I answer that? Now I say n into log power C, n is larger, you put C is equal to 2. If I say it is smaller, you do something else, okay? That C value, it depends now. If C is greater than 3, then that fellow is larger. If C is smaller than 3, then that is smaller than that. Mr. Isai Tech asked something like this. N log cube n, n log power Cn. See, whenever such problem comes, you cancel out common terms. You cancel out common terms. You have to compare these fellows now. Based on that, you will get the answer. Based on that, you will get the answer. Correct or not? Now, what about this, my dear friends? What is the answer for this? Next problem. No one? See, my dear friends. Yeah, Prajwal Nizara solved it. B. Nishu Kumar says B. Prajwal Nizara says D. CD. Oh, C and D. Ayush Thakur says CD. Oh, very good. Getting good answers. Saubhagya Naik says D. Okay, sir. Let me start my solution. Now, actually, Fn is n power root n. Then Gn, let me play with this first of all. 2 power root n log n. This can be written as 2 power log, see you all know this, a log b can be written as log b power a. So that is what I am doing. Root n log n can be written as log n root n. Now we have a power log b is there. You can swap a and b, my dear friends. That is, it can be written as b power log a to the base c. You can write it. That is, I am swapping this. Sorry. I am swapping this 2 with this fellow. Am I clear? So what happens to this? This fellow will be n root n log 2. Okay, LG, no? LG means log to the base 2. Log 2. So this is log 2 is 1, so it is n root n. So which clearly mentions that, okay, it may be 3, sir. Let me write that 3, no problem. So Fn is 3 times n root n and Gn is n root n. So they are asymptotically equal. F and G are asymptotically equal. F and G are asymptotically same. These two are same. Now what about n factorial? Recently I shown you n root n and n factorial. You know n root n, let us consider this n root n and n factorial. Let us consider these two fellows. Now what you do, you apply n root n power root n. You apply log on both sides. Log n root n and log n factorial. And n root n, log n root n is root n log n. And it is asymptotically equal to n log n. Which one is larger? Which one is larger? Log n log n is larger than root n log n. So obviously this is smaller than this. So because of this, we can say that n root n is smaller than n factorial. So what we got here is f and g are asymptotically equal and both are smaller than h. This is the result which you got. So once you got this result, you play with these options now. H is big O of, both are smaller, asymptotically smaller than h, my dear friends. So h is big O of Fn. That is, h is asymptotically smaller or equal to f. That is wrong because h is larger. H is larger than f and g. But this is saying that h is smaller or equal to Fn. That is wrong. H is smaller or equal to Gn is also wrong because of the same situation. Gn is not big O of Fn. See, my dear friend, when f and g are same, you can say f is big theta of Gn, f is big O of Gn, f is big omega of Gn. But he is saying not, therefore it is wrong. So what is the correct option? Fn is big O of Gn is correct option. See, depends on the topic na. Sub topic, sub type of questions मिल जाएगा. Yeah, it is smaller na. Smaller. It is smaller. The next one. Next problem. Next problem. Next problem. What is Tushar Shushodia? What is your doubt? N factorial you mentioned. What is the correct order, my dear friends? What is the correct order for this? A is the correct answer. See, first of all, let us go with the natural ordering. First of all, let us go with the natural ordering. 2 power n is dominating fellow so far we know. We are having doubt with this, we'll deal with this. N power 3 by 2 means n power 1 into n power half. That is n power 3 by 2. N power 3 by 2 is n root n. Correct or not? So obviously when you compare n power 3 by 2 with n log n, n power 3 by 2 with n log n, this is n into n power half, and if you take the common factors out, you get n power half and log n. Obviously n power half is larger, so C is smaller than B. C is smaller than B, you got it. C is smaller than B, you got it. And obviously B is smaller than 2 power n, you got it. Now what about n power log n, my dear friends? Now the question is, what about n power log n? Now if you consider n power log n, am I clear? If you consider n power log n and n power 3 by 2, what you do? You apply log on both sides. Apply log. When you apply log, what happens? This is log n into log n, whereas it is 3 by 2 log n. 3 by 2 log n. Now what happens to this, sir? Log n whole square, that is log square n, and it is log n. So which one is larger? Obviously n power log n is larger. N power log n is larger than n power 3 by 2. So n power log n is larger than n power 3 by 2. So the next ordering which you got, we already made that C is smaller than B. Now we proved that B, we compared with B with D. So we got B is smaller than D. Now final comparison, you compare D with AN. 2 power n obviously dominates. If you know that directly, you can write it. Or otherwise you can apply log on both sides and verify. See, my dear friend, by applying log, we can easily verify this, my dear friends. By applying log, you can easily verify this, my dear friends. Okay. Overall log also you can apply and you can verify this. Overall log you can apply and you can verify this, my dear friends. See, if you want, on all the functions, when you apply log on all the functions, the first function an will be, when you apply log, what happens to this? It becomes n log 2. And on bn, if you apply log, it becomes 3 by 2 log n. I am just writing the factor. Now cn, when you apply log, it is log of n log n. Log ab is nothing but log a plus log b. That is log n plus log n. Then dn is log n whole square. Now if you consider this, you are having a problem with BC, but BC can be handled directly. So clearly you know that BC are smaller than D. Am I clear? Out of BC, which one is smaller? Out of BC, C is smaller. So C is smaller than B. How can you identify that, sir? When you consider n power 3 by 2 and n log n, this is nothing but n into n power half and it is n into log n. If you remove the common factor, n power half and log n, out of these two, which one is larger? N power half is larger. So this is larger means this is larger. Okay. So out of CB, which one is larger, my dear friends? Out of CB, which one is larger? B is larger. That is B is larger than C. So out of BC, B is larger. Therefore, you get C smaller than B, and then comes DN, and finally N. That is A. So this is how we can find the ordering for these functions, my dear friends. just apply log. But when you get same order, for example, these two are of same order, you can't conclude anything. If log is same, you can't conclude anything. You have to verify by some other means. That's why I verified by some other means here. Am I clear? No, no. There is no such constant values you can find it. Functional values you can't find it. Is SI-tech. You can't do that. No. Next problem. Next problem. Yeah, next problem. Yeah. How many years, sir? Okay, here. See, generally for this type of problems, now you just write down the real line. You just write down the real line. Okay. You just write down the line. The points are like, 0 is a point or 100 is a point. Then there is a 10,000 point. Now, if you see up to 100 G to N is N, and up to 100, because up to 10,000 it is N cube, so up to 100 also it is N cube. So up to 100 G1 is N cube. So the dominating fellow I am writing above the line, smaller fellow I am writing below the line. G1, which is N cube, and it is G2, which is N. And after 100, this fellow is, that is G2 is N cube, and G1 is also N cube, my dear friends. That is, they are equivalent from 100 to 10,000. But after 10,000, what happened, sir? After 10,000, what happened? G1 value changed to N square. So G1 is N square and G2 is still N cube. But when you consider asymptotically, that is long run behavior, which one is dominating, sir? G2 is dominating. G2 is dominating. So actually here G1 is asymptotically smaller or equal to G2. G1 is asymptotically smaller or equal to G2. So G1 is big O of G2 is correct. G1 is big O of N. It is not big O of N. G1 is big O of N square. So it is wrong. G2 is big O of G1 is wrong asymptotically. G2 is big O of N. This is wrong because G2 is big O of N cube. Therefore it is wrong. Got it? Babu, numerical answer type. Please answer this. Please answer this. Just 1 minute. You answer this meanwhile. Just give me 1 minute, I'll be back. Try this problem. solving it. What was the answer? What is the answer for this, my dear friends? What is the answer? Three. Anantadatta says 3. Let us see. Anantadatta says 3. Let us see. Six. Good. Ayush Thakur, Pranab Paul, very good, Nana, super. Very nice. Yeah, taking 1 minute, nice. There are two algorithms for processing a file having 2 power x records. Algorithm A takes time 8n log n and algorithm B takes a time n square respectively for processing these records. The smallest value of x for which algorithm A is asymptotically smaller than algorithm B. So if you take A and B, so 2 power x means 8 2 power x log 2 power x here, and here it is 2 power x whole square. And you want this to be smaller than this. Means what? 1 2 power x you can cancel, and you can send 8 2 power x to the other side. You get log 2 power x is smaller than 2 power x whole square by 8 2 power x. So this is nothing but x into log 2, that is x smaller than 1 2 power x cancel. You get 2 power x by 8. So what should be the value of x for which this condition is satisfied? There can be many values. So someone said 3. If you put 3, what happens? 3 less than 2 cube, that is 8 by 8, which means 3 less than 1, which is wrong. So x is equal to 4 also it won't work, because 4 less than 2 power 4 by 8, that is 2. 4 less than 2 is wrong. X is equal to 5. 5 less than 2 power 5 by 8, that is 5 less than 4 is also wrong. So x is equal to 6. If you take 6 less than 2 power 6 by 8, this satisfies, because 6 less than 8 is correct. So correct answer for this is 6. Correct answer for this is 6. So there is a scholarship test going on. You will get up to 90% scholarship, my dear friends, on the preparation of GATE programs. You can happily avail this particular scholarship. Up to 90% scholarships you can get it. Okay, and it is on 8th January at 12 p.m. You can register on BYJU'S Exam Prep app. Okay, you can register on BYJU'S Exam Prep app, my dear friends. Take a step towards success in GATE. It is a time for advertisement. So now let us take up problems on time complexity, my dear friends. Now let us take up problems on time complexity. You know, time complexity is number of statements totally executed into cost of the statement. That is how we approximate time complexity, my dear friends. Of course, this is the basic what you call abstraction, and another abstraction is your order of growth notation. Another abstraction is your order of growth notation. Okay, standard ones. Let us see whether you people remember standard ones. Now these are all very, very simple problems. I think most of you are all experts in this. So let us see, first of all, the standard rules. You people know it or not? I am giving very, very standard rules. I want answer very, very quickly, sir, for these fellows. Remember them as result or problem. What is the answer for this? What is the answer? Pranab Paul, D. Prajwal Nijara, T. Very good. D is the correct answer. Theta N. Standard simple problems, sir. These are all standard results. I am giving it as problems now. It's like, verification. Do you remember the formulas or not? Standard result you remember or not? Next one. Next one. Very good, very good. People are answering like, wow, rock solid. Super, super. Nice. So when you are going from 1 to n in multiples of any constant, 2, 3, 4, 5, or from n to 1 with division of a fixed constant, the probability will, or sorry, the complexity would not probability, sir. The complexity would be log n, my friend. The complexity would be log n. Now, what about this? What about the next one? What about the next one? Answer fast. Now, we move on to the next level. From here onwards, most of you are comfortable. So, let us answer quickly. So, when it is starting from 2, you have multiples of, that is every time you are raising to the same power c and reaching n. It's like, 2 is there, next time 2c, 2 power c square, and you are reaching up to 2 power c power k minus 1, and you want to reach where, sir? You want to reach 1. Correct or not? Sorry, you want to reach n. Then what is c power k minus 1, which is log n? That is k minus 1 is what, sir? Log n. Actually, it is 2 base 2, here base c, but base of logarithm does not matter. Base of logarithm does not matter, my dear friends. Okay? Base of logarithm does not matter. Hardly it affects the constant variation. Therefore, you can take the answer as theta log n. Theta log n is the answer. This is B. Harsh Modi. The answer for this is log n, standard one. Or you are coming from n to some constant 2, and every time you are raising it to the power 1 by c, 1 by c, 1 by c, still the answer is log n. Standard 3 rules I want everyone to remember. Good for help. Okay, no problem. Base will be c, sir. Base will be c, not k. Base will be c. Yeah, correct. Hardly it matters, sir. You can easily deal with it. That is not a big deal. Good morning, sir. Please solve this problem. Now let us solve problems. Come on. Expecting good number of answers for this. Just now we seen applying the rule. Get the answer. B, theta n square. Wow. D, theta 1. Kaustubh Nageshwar says D. Saubhagya Naik says B. B again. Wow. CS Vision by E.R. Chandan Kumar. Very good. Harsh says B. Pranab Paul says D. Suraj Mishra also says D. Now people started thinking about this option. Very good. Prajwal Nizara, Saubhagya Naik again changed his answer to D. Very good. See, my dear friend, here the value of x is 100 and n value is fixed here. N value is fixed here. N value is 100 here. So when you fix n value, even though it is varying up to 100 into 100, 10 power 4, but it's a constant only. Okay? Therefore, yes, Chandan Kumar also changed his answer to D. So everyone changed his answer to D because total constant number of times. See, whether it is 10, 100, 1000, 10,000, 1 lakh, everything is a constant variation only. So asymptotically, it is theta 1 only. Asymptotically, it is theta 1 only. Next problem. What is the answer? Harsh Modi says theta n. Kaustubh Nageshwar says C. Ayush Thakur says ye. Arya Kaurav says ye. Theta n. See the continue, hopefully you all understood what is continue. See the remaining work in that loop will be ignored and you start the next iteration of the loop. But here there is only one work in that, so nothing to be left, automatically the entire loop will continue, my dear friends. So we start with I is equal to 1 and every time you are adding how much, sir? N by 10 you are adding. Next time you are adding n by 10. Next time you are adding n by 10. How many times you add n by 10, my dear friends, to get n? Sorry, it is I plus na I. Sorry. It's not n by 10 plus I value. Sorry. I is equal to 1. Next time I is equal to I plus n by 10. Okay. Next time it is again n by 10. So when you do this 10 times, 10 n by 10 will give you n. 10 n by 10 will give you 10 n. So how many times you are iterating, sir? How many times the loop iterates? Approximately 10 times, which is constant variation. So the answer for this problem is C, my dear friends. Answer for this problem is C. That is theta. Small variation. Next problem. Good. Hopefully you understand that. What is the answer for this? Harsh Modi says C. Suraj Mishra says A. Kaustubh Nageshwar says A. What happened? See, my dear friend, is it not same as the rule which I given? For I is equal to 2, I less than or equal to n, I is equal to I power C. I given this rule, na? We already discussed this. The complexity of this is what, sir? Theta log n. The same thing. Instead of C, I given 2. Sometimes 3 may be given, sometimes 4 may be given, sometimes 5 may be given. Be ready for that. See, when you learn these standard rules, na, plan with different numbers. Practice with different numbers. Don't just practice like I plus C, I by C like that. Practice with different numbers so that you can fix them and you will remember them for long time. Got it? Like that. Next one. What is the value of J after execution of the following C code segment? B. Suraj Mishra says B. Ananta Datta says B. Anyone quickly? Of course, quickly in the sense if once you complete your answer, don't worry about other speed. Take your time, but don't take too much time. B. Most of the people are going for B. Oh, is it so? Let us see. Here, actually, these are the two initializations. This is the verification end condition, and this is the incrementation. I value starts with 1. Every time it is multiplied by 2, that is 2, 2 square, 2 cube, and you want to reach n. Let us assume that the kth term is equal to n. So what is the kth term here? 2 power k minus 1 is equal to n. So this is when I value reaches n and you come out of the loop. But here what is happening every time when I is incremented, j value is initially 1. To j, the I value, current I value is added. And always the comma operator varies from left to right. So first I value incremented to 2, that is added to j. So j value initially 1, to that I value, that is 2 is added. Now next time j is 1 plus 2, to that I value is added. Next time I value is added. So this is what gonna happen, my dear friends. But here when it is 2 power k minus 1, you come out of the loop. That is, you actually added 2 power k minus 2 and I value incremented to, I value is 2 power k minus 1 means what, sir? I value is 2 power k minus 1 and 2 power k minus 2, then j is equal to that 2 power k minus 2 is added, then I is less than or equal to n, you enter the loop. Now I is equal to 2 power k minus 1, then j is equal to added 2 power k minus 1 is added. Now it is equal to n, you entered. Next time I is equal to say 2 power k, I is equal to say 2 power k, j value that 2 power k is added, but because it is greater than n, you come out of the loop. So this is the value of j, my dear friends. This is the value of j. So which is geometric progression. Okay, that's what we'll get one more. For I is equal to, maybe it is n, it is entering now 2 power k minus 1, it is n. So then what happens? It is getting inside the loop. Then what is happening, sir? I will be 2 power k next time. That time it will come out of. That's why I added 2 power k also, no? That's why I added 2 power k also. Am I clear? I think many people quickly answered here. Now here sum of geometric progression, k plus 1 terms. That is 2 power k plus 1 minus 1 by 2 minus 1. So it is 2 power k minus 1 is n. So maybe it is 4n minus 1, which is nothing but some theta n. So the answer must be C. Answer must be some C. Not, answer must be C, not B. Most of the people initially said B. Now they changed the answer to C. Hope you understand, the answer is C, not B. Hope you understand? Hope you understand. Is the idea clear? See this type of problems. See, sometimes what they do, they keep that j value inside the loop. But here what is done is to confuse you, the j value also included within that for loop only. Otherwise, the same problem can be given something like this, sir. For I is equal to 1, j may be initialized here, and I less than or equal to n, I into 2, they may do j is equal to j plus I. Okay? Nothing, sir. This is same as this problem. This problem and this problem are one and the same. Am I clear? But the small variation here is, in this what happened after this verification of the condition, you enter inside the loop. But here what is happened? See, if you write inside, this particular value may not be added. This particular value may not be added. Because it is within the loop, this 2 power k is added extra. That small variation will happen. That small variation will happen. See, Asymptotically, we don't have any problem, sir. But if you want to find exact value, then you have to take care of what is happening exactly. But asymptotically, when you take that is not a problem, because you get 4n or 6n or 2n. Does it matter to you? Hardly matters. Got it? Like, of course, this one is different from this. The idea is same. That is what I am trying to say. But sir, I less than or equal to n, we have to check the value of I only na. Yes, sir. See, I value only we are checking, but there is one more condition which is or one more what you call the increment which is happening. That also will happen. But this, I think you are confused with the particular problem, sir. Of course, we are verifying the condition only. That condition will help you in iterating the loop. But the question is about what is the value of j. The question is about what is the value of j. Hope you understand, Mr. Pranab Paul. The question is about what is the value of j. That is what we are solving. How many times the loop iterating, we are not saying that. How many times loop iterating, we are not saying that. Got it? Then your answer is correct. But we are not saying how many times the loop iterates. We'll see. Mohan Bihari, we'll see that. Answer this question. Now let us see. I'll give you simple problems, small googlies. Let us answer them. Yes. Quickly answer this. So generally we do this, sir. This outer loop and inner loop, they are independent, because inner variable or inner rectangle or the variable of inner loop does not affected by outer variable. So we call this type of loops as independent nested loops. We call it as independent nested loops. So outer loop iterates how many times, sir? See, when I said don't say, sir, n plus 1, n minus 1, approximately n times. And outer loop iterates n times. What about inner loop? What about inner loop, sir? J into C up to n, it iterates log n times. So it is n log n, straightforward question. Next one. Very good. Yes. Good. Yeah, you can do that. Next one. See carefully, sir. See carefully. Okay, very good. People are perfectly answering this. This is n times and it is log n times. So option B is the correct answer. Hi Babu, why A, sir? Tappu. A is wrong. A is bomb blast. It is J to J square. J power C, the third rule which I given. The third rule. Please note that, Babu. Please be careful. All of you able to follow? Agla samasya on your screen. The next problem on your screen. Answer this. What is the answer? Super. Simple only, right? See how many times the outer loop iterates? N times. The inner loop iterates how many times? See here 2 power n in multiples of 2. Actually, it is log 2 power n times. But log 2 power n is same as n log 2, which is same as n. So it is n square. N into n square is the answer. n into n square is the answer. I think it's a simple problem. Next problem. You people are answering rock solid. Next problem. See, sometimes you think too much, they'll ask you very straightforward question. Okay? And you take very light, they ask you some twisted question. So you have to be careful, that's it. Whether it is a simple problem, little twisted one, you should be in the same frame of mind. Keep it cool, see what is given, answer it. It is not a difficult problem at all. Very good. So here we are starting with n by 2, Babu. We are starting with n by 2. So n by 2, when you multiply in single iteration, you reach n. So it is one time or constant times. It is constant and it is log n. So constant into log n. So option is theta log n. See, sometimes to trouble you, they can give you more nested loops. This time I am not taken. See, that is why we write so many test series and all. Okay, so many test series. Why you write? To keep that cool only. That's it. Next one. Next one. Yeah, next one. What is the answer? Now you see you are answering every question properly. See, there are odd questions which fails. Nice, let it. So here j square is n. J square is n means j is root n. So here you are iterating root n times. Here it is log n times. Root n log n is the answer. And sometimes be careful, my dear friends. In addition to this, there may be some semicolons and all. So you be careful with these notations and all. Okay, I don't want to trouble with all those things. Okay. Next question. Next question. What is the next question? Anyone answered? Very good. Pranab Paul. Very nice. Nicely answering. So here it is log n times. Whereas here it is log n square times. But log n square is same as 2 log n, which is approximately log n only. Asymptotically log n only. So log n into log n, log square n by difference. Log n into log n, log square. The time complexity of the function in terms of theta notation is what? The time complexity in terms of theta notation is what? So for sometimes, let us do this way. Okay. What is the answer for this? So it is Hyderabad ठंडी है, होती है थोड़ा बहुत. but it is not that troublesome as North Indian Thandi. Month of January, I know that how difficult it is at North India. We used to take classes in North India. No, here I don't have that much Thandi. Now you are saying very difficult. In that particular times, we used to take classes. That would be very, very interesting. Yes, sir. The next problem. Yeah, what is the answer? No one answering? No one answering this? Anyone answered? C, na? Someone said C. Yeah. Someone answered already, yeah? Yeah, C. Okay, C. See, it is very simple. This is a very common, very important for loop, my dear friends. I always tell students. Here what happens, J value depends on I value. These are called dependent nested loop. And this is one of the very, very important type of nested loops. Here what happens, when I is equal to 1, J varies n times. For I is equal to 2, J varies how many times? N by 2 times. For I is equal to 3, J varies n by 3 times. So it's like n plus n by 2 plus n by 3 plus and so on, roughly up to n by n times. Taking n common, it is 1 plus 1 by 2 plus 1 by 3 plus and so on up to 1 by n. And you know, harmonic series approximates to log n. So it is n log n, my friends. So the correct option for this is C. Very good. Now we move on to the next topic, master theorem. This is a rule. Hopefully all of you know the statement of master theorem. I quickly move to the problems. Okay. So within the problems, I'll be discussing these statements, my dear friends. Of course, the regularity condition, generally we don't use that, because when it is a polynomial function, the regularity condition is obviously satisfied. Or if it is a very, very big exponential functions, they also satisfies this. So generally, we very rarely use this regularity condition. But for the third case, we have to verify the regularity condition to answer the questions. You can't directly answer the question, Bob. Please remember that. Hope you understand. Now let us see this problem. Simple, straightforward questions I am asking. Just verify the cases. So here, the basic idea for master theorem is, it is a fight between n power log a to the base b with fn. If n power log a to the base b dominates, theta n power log a to the base b. If fn dominates and regularity condition satisfies, then theta fn. If both are equal, you multiply with log n. Of course, there are some variants of this. We'll discuss immediately after this. So, of course, yeah, that same thing, sir. See, this, you know, here, what is this? Here n power log a to the base b dominates. For that, you are saying a is greater than b power k. No, that is only possible for polynomial fellows. That is possible only when it is n power k form. Because it is n power k form, you can obviously use this. When it is a polynomial form, you can use that particular extended master theorem. Your wish. So what is it? It is n power log 8 to the base 2, which is nothing but n cube. And here it is n square. Obviously n cube dominates, so theta n cube is the answer. Theta n cube is the answer. See, mostly we don't even need that extended master theorem, my dear friends, because basic master theorem will do most of the problems in GATE examination. Next problem. Quickly answer. Simple questions I given. So here 2 power n dominates. Very good. C is the correct answer. because here n power log 1 to the base 2. Here that extended master theorem doesn't work versus 2 power n. Obviously this dominates. Am I clear? So theta 2 power n is the correct answer for this. Theta 2 power n is the correct answer for this. Next one. Here extended master theorem also works. What about this? What is the answer? See, for master theorem, hardly 10 seconds. We should write the result in 10 seconds for master theorem, or maximum 20 seconds, not more than that. N power log 4 to the base 2 versus n. So it is n square. So who is dominating? N square is dominating. So theta n square. Next one. Yeah. B. Very good. N power log 3 to the base 2 with n square. Obviously n square dominates, so theta n square is the answer. Okay, Babu. Next one. See, I want answer within fraction of seconds. For this, see, for these 6 problems, I just assumed 1 minute time total. 1 minute time I assumed. CS Balaji says, very good Balaji. Super Balaji. Balaji says, how much answer? D. Very good. Babu, ye evaru? Babu, Ayush Thakur, ye kaadu nana. Check chesko. Here, n power log 2 to the base 2 versus n. Both are n only. So n is asymptotically equal to n. So by case 2 of master theorem, it is theta n log n. Next one. A, C. Pranav Paul says C. So here it is n power log 2 to the base 4 compared with root n, Babu. Okay. So log 2 to the base 4 can be written as log 4 power half to the base 4, which is nothing but n power half versus n power half. Both are of same order. So multiply with log n. Babu, all of you know these rules of master theorem, or you want me to explain this rule once again? Is it fine for all of you? Super. The next problem. See, Saubhagya, for quick reference for Saubhagya Nayak. See, my dear friends, in a very simple sense, what you do is, you find n power log a to the base b and fn. If n power log a to the base b dominates, highest, that is case 1, because fn is smaller than n power log a to the base b. See, here he says n power log a to the base b minus epsilon. See, log a minus epsilon. That is, even if you remove something, still this is dominating. That is, this is the highest fellow. N power log a to the base b is highest. In that case, what he says, In that particular case, what he says is Tn is big theta of n power log a to the base b. That is, this will be the answer. Theta of this will be the answer. Suppose the third case, if Fn is highest, that is Fn is big omega means Fn is larger than n power log a to the base b. Not only that, even if you add some epsilon also, still it is Fn is dominating. Still Fn is larger than n power log a to the base b. In that particular case, theta of Fn is the answer. Of course, here the regularity condition to be verified. But as I told you, if it is a polynomial function, you need not verify, because for polynomial functions, regularity conditions obviously satisfy. And the most interesting thing is when both are of same order of growth. This fellow and this fellow are of same order of growth. In that particular case, just you can take either n power log a to the base b, or you can take Fn. You can take any one, multiply with log n, if both are of same order of growth. Clear? Now look here. In this case, n power log a to the base b is highest. N power log a to the base b is highest. So theta n cube is the answer. In this case, 2 power n is the highest. Fn is highest. So theta 2 power n is the answer. In this case, n power log a to the base b is highest. So theta n square is the answer. In this case, Fn is highest. So theta n square is the answer. In this case, both are same. Both are same. So what happened? Just multiply with log n. N log n is the answer. And the last one is, again both are same. See, it is n power half, n power half. Both are same. So what is the complexity? By case 2 of master theorem. Theta n power half means root n log n, my dear friends. Hope you understand. Is the idea clear? All of you able to follow, Babu? Clear or not? Yeah, it's a quick method. Now let us solve this problem. Now let us take this problem, my dear friends. Please solve this problem. I want all of you to try this problem now. Try this problem. Try this problem. B. Is it B? I doubt. A. Is it A or B? Let us see for some time. Let me go out and deal with the problem now. Now look here, sir. If you take this particular problem, here An is time complexity, so you can write An or Tn. So what is the time complexity here? For n is less than or equal to 2, it is constant. And for n greater than or equal to 2, greater than 2. For n greater than 2, it is a root n, that is t of root n plus 1, 2 times. 2 times t of root n plus 1. Is the idea clear? Any doubts? Yes or no? Now you have to find this t of n, 2 t root n plus 1. Root recurrence relation you want to solve it. See, here you can make one substitution like n is equal to 2 power m. With this substitution, what happens, sir? This will become t 2 power m 2 times t. N is 2 power m whole power half. Therefore, it becomes 2 power m by 2 plus 1. So, by taking t 2 power m as some function of m, it changes to Sm is equal to 2 Sm by 2 plus 1. Now, what happens? You can apply master theorem. Master theorem we can apply. by master theorem, what happens to this? What about the solution for this problem, my dear friend? By master theorem. By master theorem, one second. Here you take m power log 2 to the base 2 versus 1. Here m is highest. So what is Sm? Which is theta m, my dear friends. But this Sm to be converted back in terms of n. So Tn, you have to write n is equal to 2 power m, means m is equal to log n to the base 2. Therefore, Tn is equal to theta. What is m? M is log n. So theta log n is the answer. So what is the correct answer for this? Theta log n. Very good answer. Quick answer. Many of you answered very quickly. Nice. The next question. Try one more. If you have any doubts, you can ask me. Try this. Previous one again. You want me to solve it again, or by other method you want me to solve it? Suraj Mishra. See, here it's all manipulation I done, because Sm is theta m, but Sm is T2 power m. Sm is nothing but T2 power m is nothing but theta m. But T2 power m is nothing but, because 2 power m is nothing but n, so substituting everything in terms of n, m is log n. That is what it is. See, if you want to do by substitution method, Babu Evaru, Pradap Paul. See this substitution method. We generally, okay. Yeah, that's what I'm saying. See that substitution is, illegal. I generally say, okay, unnecessary strain for brain, nothing more than that. Am I clear? You are not doing intelligently. Don't ever do that. Okay. See, that is done by non-mathematics people. Am I clear? Because that comes after a lot of practice. It is a lot of nonsense, unnecessary work. I am telling you, if you are doing by direct n, you are wasting your energy and time. That is not intelligent method, my friends. Please don't do that. Okay? Please don't do it. Okay? See, it is always 2 power k, you substitute it. How simple it becomes. In a simple nutshell, you can solve this problem. And T2 is equal to 1 here. So when you do this, it is T of 2 power k. See, that's what. No. I cannot test my patience here now, sir. This is not the time. Maybe some other time where we deal with only, the recursion method or recursion tree methods also we'll discuss. Then we can do it. It is not a time to deal with those things. Okay. So if you are expecting that, it is better waste of energy and time. Am I clear? I am not doing that now, sir. Right? Next one. This one, anyone completed? This one, anyone completed? Yeah. See, here also, you put n is equal to 2 power m. Then what happens to this? T2 power m is equal to 2 into 2 power m by 2 plus log 2 power m. That is nothing but T2 power m 2t power m by 2 plus m log 2. Wonderful. We are solving it now. Right? So let us take T2 power m as some function of m. So therefore what happens to this? This is Sm 2 into Sm by 2, and M is M only, don't mess up with this, sir. This you don't have to mess up with this. Then what happens to the time complexity of this, sir? When you see apply master theorem, by master theorem, so what happens to this? It is M power log 2 to the base 2 compared with M, which is M versus M, which is same order of growth. Therefore Sm is equal to M log M, but Sm is nothing but T2 power M, which is nothing but M log M. Converting back to N, what is M? What is M here? N is 2 power M, therefore M is equal to log 2. M is equal to log N. M is equal to log N. Log N into log N. Log N into log N. Got it? That is the answer, my friends. That is the answer, my friends. Hope you understand. Super. Actually, formation of recurrence relations I am not doing in this. Maybe I'll try to do some formations and all in the discrete mathematics part. Okay. So here we are only interested in solving recurrence relation rather than formation of recurrence relation. That is very interesting topic. Of course, that is useful for our dynamic programming, even divide and conquer also. But this session I'll be more concentrating on your problems on algorithms or solving recurrence relations. Yeah. See, there is something called extended. Yeah. Later on, together with mathematics, we'll take, sir. Together with mathematics, we'll plan. Together with mathematics, we'll plan. See, this is extended master theorem, sir. Actually, the idea is same for this and the previous master theorem, one and the same, sir. Okay. See, in master theorem, you do n power log a to the base b. And here he is comparing a with b power k, you see. See, suppose if a is greater than b power k, here the idea is one more important point to be noted. Here Fn is n power k. Fn is n power k. In this what happens when a is greater than b power k, so here you are going to get n power k plus something. So obviously when a is greater than b power k, n power log a to the base b is dominating term. This is the dominating term. This will be higher. And when a is same as b power k, when a is same as b power k, both are of same order of growth. Both are of same order of growth. Am I clear? Then n power log a to the base b is same as n power k. And when a is less than b power k, n power k dominates. These are the three cases of our master theorem only. But here there is an extra factor which is multiplied with n power k. And when you have this particular extra factor, that is log power pn, when you have this log power pn, then also we can handle based on the value of p. The first case does not matter. It does not depend on any value of p, because when n power log a to the base b dominates, obviously theta n power log a to the base b is the answer. N power log a to the base b is the answer. But when both are of same order of growth, that is a is equal to b power k, when a is equal to b power k, in this particular case, depending on the value of this power p, we have different solutions. P can be greater than -1, P can be equal to -1, or P can be less than -1. See, P greater than -1 is, you get log power P square or log cube P, log power 4P, something like this. Suppose when P greater than 1 and this particular situation happens, you just increment the power of log by 1. Increment the power of log by 1. When it is P is equal to -1, it is simply log n. What you do? You just multiply with, instead of multiplying with log n, you multiply with log n, my friends. And when P less than 1, you don't do anything, just theta n power log a to the base b you write down. That is, that factor is not contributing term, so you can ignore that factor. And when a is less than b power k, when a is less than b power k, what happens? Again, based on the p value, p positive or 0, then n power k log power pn. That is same, this factor you are going to get as the answer. But that is obviously this is the dominating factor. But when p value is less than 0, even though this factor is there, that factor has no effect, that can be ignored by difference. See, in both the cases, you see here and here, that factor was completely ignored. That factor was completely ignored. See, this formula not needed, but worst case, if at all they ask this n power log, because this is also a theorem, this is proved, sir. It's called extended master theorem. The formal proof is given for this. Okay, so you can't say I don't want to do it, but mostly in GATE examination so far, the questions which were asked are based on only master theorem. That is enough. Okay, if you know it, it's good for health. What is wrong in that? Hardly 2 cases, sir. See, hardly here. See, this is the case. These are the 2 cases which we need to consider. This case is exactly same as our previous case only, sir. Let us use it then. Because this formula is very useful for test series. Because mostly test series, they'll give you questions from this only. Yeah, next one. What is the answer for this? Yeah. So what is the answer? Most of you are answering B. Very good. See, my dear friends, here if you observe, actually A value is 6, B value is 3, and here it is n power k, k value is 2 here. So most of the people try this. A is b power k. B power k means what, sir? B power k means A value is what, sir? 6. So you just compare 6 with 3 square. Is it less than, equal to, or greater than? It is less than. So 6 is less than 3 power 2 means it is third case. It is third case. Case 3 of extended master theorem. So you have to see the value of P. What is the value of P? P is equal to 1, which is greater than or equal to 0. So what is the answer? Whatever is here, that is the answer. So the complexity would be theta n square log, which is option B. Next problem. What is the answer for this problem, my dear friends? Yes. Very good, Dana. Ashwini, correct. Next problem. Ayush Thakur says B. B is the answer for this. Let us see. A is 5, B is 5, K is 1, and P value is minus 1. P value is minus 1. So consider 5 and 5 power 1. Both are equal. Second case. So when it is second case, yeah, I'm fine. Okay, sir. Second case, Second case, it depends on the value of p. P greater than -1, p equal to -1, p less than -1. It was a viral fever, so suffering from that. So that is the problem. Was having some issue. Okay. So what is it? What is this, my dear friend? Phi is equal to second case, case 2 of EMT. So now p value will decide. P is equal to -1 means second case. Second case, p is equal to -1. What happens? Whatever answer you get it, either this value is there, no, you have to multiply with that same n is there, no, you have to multiply with log n. So Tn will be n log n. The common term is here, that is like actually in master theorem what happened? You see n power log a to the base b and n both are same. That has to be multiplied with the factor log n. That has to be multiplied with the factor log n. Yeah. Taking care, sir. Okay. Now I taken a sitting and teaching you. No problem. Next one. Next one. What is the answer? See, my dear friend, of course, here I am giving, but how to practice this, let me tell you. Okay, first let me complete this, then I'll tell you how to practice this. Here also, a is 2, b is 2, k is equal to 1, p is equal to -2. Then what happens? A is equal to 2 power 1, both are equal. Second case, p is -2. So what happens? It is simply big O of n square. Or, sorry, what is that particular answer? P -2, no? Third case of EMT, na? P is -2 only, na? -2. So what happens? That factor will not have, because both are of same order, no? So what is the answer for this? Tn is equal to big theta of n. That log factor will not have any effect, as I mentioned. Log factor will not have any effect. So it is theta n only, my dear friends. Theta n only, my dear friends. See, always try this way, sir. Always whenever you have such problems, na, just take some random examples, numbers, and practice with that. Practice with them. See, here it is always Tn when you keep it. T. You first fix something here like n square you fix. So what happens here? A Tn by b. So you can just 2. It is b here. So it can be either 2 square, more than 2 square, less than 2 square, or 2 square. So you can try with 4 or less than 4 numbers, greater than 4 numbers. Then you can just keep on changing this value. Like that you keep different numbers and practice. With this what happens? You will get good practice of this particular rules. See, always fix something and keep on practicing with the different numbers. Suppose you keep 4. You keep 4 here means you are talking about second case. Then you keep on changing the values of p here. You keep on changing the values of p here. For example, if I put log square n, the answer should be equal to what, sir? N square into log cube n. Immediately you should be able to say that answer, my dear friends. Immediately you could able to say that particular answer, my dear friends. Hope you understand. So please practice like that. That is good for health. This is called subtract and conquer theorem. There is a variant. Of course, here we have 3 results we mentioned, but generally the first case never happens. Mathematically it happens. Am I clear? So practically it may not happen ever. But let us see the 3 cases of this subtract and conquer theorem, where you are having this particular Fn is of the form polynomial. See, generally what happens? Just go through it, sir. Just give me 2 minutes. Just give me 2 minutes. I'll be back. Huh? Just try, go through this rule. I'll be back in 2 minutes. Hi guys, sorry. Nothing happened, sir. Everything is fine. Yeah. So shall we continue, sir? See, this is your subtract and conquer theorem. Subtract and conquer recurrence result or theorem, you can call it. Here, when you are having the form like a into tn minus b and fn, see, this rule is applicable. See, there are so many slides are there, sir. Generally, it won't be completed, but let us see as many as I can complete in next half an hour or 45 minutes. Okay, because this recurrence part is completed. Now the rest of the part is simple only. They are all problems on divide and conquer. They are all simple only. Okay, that will be done faster. Problems only. They are all simple problems only, because you all know the formula. So that won't take much time, sir. See here, a and b values based on that. Actually, mainly a value. A is less than 1 or a equal to 1 or a is greater than 1. Based on that, we have this particular result. See, it is applicable when fn is of polynomial form, not for every function. So people blindly use rules for every function. No, you can't apply it for every function, sir. This is applicable only for polynomial function. Please note that point. Please note that point, my dear friends. Right? So when a is 1, it is just order n power k plus 1. But when a is greater than 1, it is order n power k, a power n by b. Okay? Now let us see this. What is the answer for this, my dear friends? Please answer this question. See, according to the rule, it is not applicable. According to the rule, it is not applicable, my dear friends. That is what this rule says. But sometimes, for brevity, we may apply that. But you have to be careful because rule is not applicable. Very good. See here, a is 3, b is 1, and k is 1. And clearly a is greater than 1. So Tn is big O of n power k, a power n by b. That is big O of n power 1, a 3 power n by b, which is big O of n into 3 power n. See, it again depends on the problem, na, whether the remaining portion it is contributing more or less. We have to see that. Okay. So that particular part generally log n is not much contributing when compared to n square. So they may ignore that particular thing. In some problems, they might have taken that. Am I clear? See, this generally happens in test series, sir. But in standard books or in standard problems, they may not be solved that way. Am I clear? You have to verify that, because one thing you need to understand, if this is the rule, with this rule you get this particular answer. With the iteration method or with recursion tree method, whatever answer you get, that is only approximation. That has to be verified using substitution method. But mostly we never do substitution. We take whatever answer with the recursion tree method or whatever answer with iteration method also, we take it as answer. That is not the correct answer. That has to be verified. Substitution method is mainly for that. Substitution method is mainly for that. So suppose, as you said, na, you get that answer, you have to verify that using substitution method, strictly speaking. Oh, wow. I purposefully removed all animations because again, what happens if I keep on animations, stories will be long. Yeah. What about this? Here a is equal to 1. A is equal to 1 is very simple. Whatever order is there, just increase by 1. Order n. And there are some special type of divide and conquer recurrence relation, especially, this result is very, very useful for quicksort algorithm, quicksort variants. Okay. See, whenever you have Tn is equal to T alpha n plus T1 minus alpha n plus beta n, the complex T is theta n log n by fx. Okay. So if you are having Tn is equal to Tn by 4 plus T3n by 4 plus some constant times n. See, here it is 1 by 4, it is 1 minus 1 by 4. So the complexity for this would be theta n log n. Again, here also the condition is this must be function of n. Yeah, this is a very, very important recurrence relation for best case and average case analysis of quicksort. Am I clear? And there is one very interesting result here. Actually, if you are having some Tn is equal to some T of some alpha 1 n, T of alpha 2 n, T of alpha 3 n, and so on. Say T of alpha k n plus beta n is there. And here alpha 1, alpha 2, and so on, alpha n are all less than 1 values. And if sum of all these values is equal to 1, then it is theta n log n. Then it is theta n log n is the answer. If this sum is less than n, if the sum of these problems, sub-problems is less than n, what happens? In this case, what happens? See, this is theta n log n. If sum of all that is equal to n, sum of all that is equal to 1, that is, these sub-problems add up to theta n problem. Then the complexity is theta n log n. If the sub-problem sum is less than n, means for example, if you are having Tn is equal to Tn by 3 plus Tn by 2 plus alpha n. Here we get 1 by 3 plus 1 by 2 is equal to, what is it? 1 by 2 plus 1 by 3 is, it's not obviously less than 1. Na? In this case, what is the complexity? You have to mention this in the comments. It's a shortcut, important shortcut. Okay. What is the complexity for this? Please let me know. You can try that. Right, sir. Yeah, shortcut hai iske liye bhi. I think in one of my sessions I done this. In one of my sessions, unfortunately people are not following all my sessions. Yeah, keep answering it. Keep answering that. We'll finalize that. Okay. I'll come to this in a time. Is it n square or n? Write the answer. Verify it is available in one of my session where I discuss, I think championship series or some series, I discuss this particular rule also. Or even in formula series also I discuss this. Even in formula series also I think I discussed it. Please check and answer here. Please check that and answer here. This is fine, theta and log n. Anyhow, by looking at it, you can answer. But if it is less than 1, then what is the complexity? Yeah. Meanwhile, we'll take one more problem, sir. Take this problem. A very popular question. Second, sir, my system struck. Second, struck. Once, yeah. Sir, I'm here, sir. I'm here. But the strict is suddenly this mouse stopped working. So I'm dealing with it. 1 second. Yeah. Yeah, this is a very famous problem. What is the answer, sir? I think most of you answered this. Yeah. See, you can use this iterative method for this Tn minus 1 plus 1 by n, which is nothing but, what is this? Tn minus 1 plus 1 by n. Now look here, sir. This is Tn minus 1. Na? See, it is like next term will be this plus 1 by n. What is this, sir? It is Tn minus 1 form. What is Tn minus 1, which is Tn minus 2 plus 1 by n minus 1. Next, what is it? It is Tn minus 2 plus 1 by n minus 1 plus 1 by n. Now, what is Tn minus 2, sir? Tn minus 2 is nothing but Tn minus 3 plus 1 by n minus 2 plus 1 by n minus 1 plus 1 by n. See, here we are doing the pattern. We are trying to find the pattern. What is the pattern? How long it has to continue? We already understood the pattern. See, it is n minus 2, then it is n minus 3. So you have to continue this till T1. So when it is T1, it would be 1 by 2. So it continues up to 1 by n minus 1 plus 1 by n. And you know T1 is 1, so it is 1 plus 1 by 2 plus and so on 1 by n minus 1 plus 1 by n. See, this iterative method is all about identifying the pattern. Those who understand the pattern, this is a simple story, my friends. So you know this is log n. So the complexity of this algorithm, or sorry, complexity of this recurrence relation is log n. Complexity of this recurrence relation is. Yeah. Anyone got the answer for this? When size of subproblems, I'll give you options. A, theta n, sum of sizes of subproblems less than n. Is it theta n square, theta n log n? Yeah, very important, theta log n. Which one is correct? Which one is correct? Anyone? I given a hint. In formula discussion, I done this. Formula series discussion. Theta n. When the sum of sizes of the subproblems is less than n, it is theta n. Remember, see, such formulas will help you a lot, my dear friends. So if this problem is given, you can immediately say it is theta n within no time, my dear friends. Please remember this. So now let us wind up with some problems on divide and conquer, my dear friends. And you all know about binary search and linear search. Best case for binary search is theta 1. Worst case and average case for binary search is theta log n. Whereas for linear search, only best case is theta 1. Of course, assuming it is successful search, my dear friends. See, the best case is theta 1, assuming it is a successful search. See, with this search problem, there is a problem whether it is a successful search or unsuccessful search. So we are assuming it is a successful search. Because of that, I am mentioning this. Right? Got it? See, you can't have formula for everything, sir. Some people with their, standard ones, they derived it. That's what I'm saying now. With standard ones, Acha, you are saying this one theta n square or this one. We don't have the rule. We don't have rule for everything, Saubhagya Nayak. Am I clear? We don't have rule for everything. Whatever rules are there, if it comes, directly use it. Others, you have to go with either iterative method or any other method available. That's it. Please remember. Yes. Now let us see the question number 1. Now these are simple problems, sir. I don't think it will take more time for you, sir, because these are straightforward questions from divide and conquer. Mostly the questions are straightforward only. Am I clear? They'll ask you complexities, which of the following is true type of questions. Mostly here the work will be with that asymptotic complexity, the recurrence relation solving. That would be the main work here, my dear friend, for the first part. 8 or 9? Okay. Now let us see. Suppose you are having say 4 entries, sir. So first time you search here, it is not found. Then you go to the right side. Then again you take mid, not found, go to the right. For 4 elements, have you done 2 searches or 3 searches? How many comparisons? Because it's compared, na? The search element is compared with this, search element is compared with this, then search element is compared with this. Worst case, how many comparisons are done? Yeah, is it not a comparison? Again, you compared with this, na? So, the number of comparisons, maximum number of comparisons. The maximum number of comparisons is given by log n to the base 2 floor of that, because that n may not be exact power of 2 na, plus 1. That will be the answer. That will be the answer. So that is log 256 plus 1. Log 256 is 8 plus 1, which is 9. So the answer for this problem is 9, my dear friends. Answer for this problem is 9, my dear friends. Sorry. Next question. Because this is a mathematical one, so generally misunderstanding in this particular question may happen. So I just thought of doing it again. In an array of 10 sorted elements, what is the average cost of searching an element or element in an array using binary search if the element is present in an array? What is the average cost of searching an element in an array using binary search if the element is present in an array? Successful search. Interesting question. Expected average cost means expected cost of search. See, the question here is average cost of search or expected cost of search or expected number of comparisons. See here, what is the cost here, sir? That is wrong answer, Pranab Paul. Here, what is the cost of the search? Comparisons, because the search element is compared with the mid element. That is, again, mid element is found, again it is compared. So how many comparisons you are doing, that is cost of the search. So expected number of comparisons he is asking. So you have to create the table for number of comparisons. Then you have to find the expected value of that, my dear friends. It's not previous. See, the previous formula is not about maximum number of comparisons. He's just asking number of comparisons. It's not expected number of comparisons. That is just number of comparisons. It is expected number of comparisons. It is the average value. Probabilistic question. It is based on the probability. Now look here, sir. We are having 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first you find the mid value. 1 plus 10 by 2, that is 5. 5 is the mid value. So number of comparisons. See, as you said, number of comparisons are 4. 1, 2, 3, 4. With one comparisons, how many elements can be found, or how many elements are having favorability? You can reach how many favorable elements? Yeah. That is the only thing for this problem, sir. There is no direct approach. Am I clear? There is no direct approach for this. Am I clear? Favorable. So with one comparison, you can reach 5. Now in the second comparison, here there is a problem, sir. Second comparison, you don't know whether you go to the left subarray or right subarray. Because search element is less than, then you go to the left subarray. Search element is the greater than element, greater than 5, you go to the right subarray. So the second comparison may be done on the left subarray or the right subarray. So the elements which are favorable to be compared, the elements which are favorable to be compared are what, sir? It may be, let me write this way. This is first, this is the element which is favorable in the comparison number 2, and here it is 2. That is either 2 or 8. Very good. Either 2 or 8 may be found. Either 2 or 8 may be found in the second search, second comparison. Okay. Next, which one is searched in the third comparison? See, in the third comparison, either you may take this subarray or this subarray or this subarray or this subarray. And again in that mid element means what, sir? Again in that mid element means what, sir? For this, it is the mid element. This is 3 for this. For this, this is the mid element, which is 3. For this subarray, this is the mid element, which is 3. For this subarray, this is the mid element, which is 3. So in the third comparison, the element found may be 1, yeah 3, yeah 6, yeah 9. Next, fourth comparison. Fourth comparison, the remaining fellow. Obviously, the remaining fellows are found in the fourth comparison. Correct or not? So let me put this, which one? This one. These 3 elements. 4, 7 and 10. See here, the random variable is number of comparisons. Random variable is number of comparisons. That is either it can be 1, 2, yeah 3 or 4. What is probability that? What is the probability that? Probability of a random, what is probability of X means what, sir? Probability that you found that element in that particular comparison. Probability that the element is found in one comparison. Probability that the element is found in 2 comparisons. Probability that that element is found in 3 comparisons. See, total 10 elements are there. How many are favorable for one comparison? Only one element favorable. This is favorable for one comparison. These are favorable for 2 comparisons. These are favorable for 3 comparisons. These are favorable for 4 comparisons. For 2 comparisons, 2 favorable out of 10. For 3 comparisons, 4 favorable out of 10. And for 4 comparisons, 3 favorable out of 10. Hope you understand. So what I want you to do is try this problem with different numbers. Like, you try this with 12, 14, 16, something like. Any odd number also you can try, sir. Try with different numbers, then you can fix this particular idea. Next time, whenever you see this problem, you will not do mistake here. Yeah. So what happens? What is expected value? Sigma x into x. So that is 1 into 1 by 10 plus 2 into 2 by 10, 3 into 4 by 10, 4 into 3 by 10. So the answer is 2.9. Very good. Nice. Okay. So here what I do is, of course, this is for MedSart. The recurrence relation and best case, worst case, and average case complexity is theta and log n, sir. See, this type of concept, synthesis questions we call them. Am I clear? Synthesis kind of questions we call them. Yeah. No. See, See, expected value, expected value can be fractions. See, we are saying long run behaviors. It would be, and not long run behavior, I'm sorry. Expected value, it can be like, see, expected outcome when a die is rolled large number of times, the expected outcome is 3.5. Now you say 3.5 is not possible, sir. That is the expected value. Am I clear? On an average, whatever answers you get, the sum or the average would be by 4. Yeah, it can be fractional, no problem. Yeah. Yeah. Try this problem, sir. They're all simple and interesting questions. Prajwal Nijara, very good, Nara. Super. Very good. So assume that a merge sort algorithm in worst case takes 30 seconds for an input of size 64. So input of size 64, it takes 30 seconds. Time complexity is theta n log n, means some constant times n log n you can take it. You have to find C value. What is the value of C, Prajwal? What is the value of C, Prajwal? So here, no, answer is fine. Answer good. All of you answered properly. What is the value of C here? N is 64 log 64. But he given it as, for n is equal to 64, it is given as 30 seconds. So from this, you can find the value of C is equal to 5 by 64. Very good. Once you got the value of C, now what is that he is asking? What should be the input size which takes 6 minutes time? Okay. Time is given, you need to find the value of n. So Cn log n is equal to 6 minutes. But everything should be converted in terms of seconds because previous answer was taken in terms of seconds. So 6 into 60 seconds. So what is n value you have to find? And here C is known. C is 5 by 64. N log n is equal to 6 into 60. So n log n is equal to 6 into 60 into 64 upon 5. Equals, I think some 72 into 64 n log n. So what is that number? Of course, you can substitute the values of n and verify. I think most of you gone after this, the value of n you substituted and verified that, I think. Right? Actually, total answer is 4068. And better to write it as 512 into 9. Because log 9 is, log n is 9 means n is 512. So it is 512 into log 512. That is exactly it is. I think mostly after this, most of you might have taken n values and tried. That is a better option. Yeah. Next question. Try this problem, sir. All of you. Okay. Suppose we have 4 sorted lists of sizes 6 elements each. They are merged into a single sorted list of 24 elements. The key comparisons that are needed in the worst case using the efficient algorithm are what? 45. Run a poll, check once again. 6 elements. We are having 6 elements. 6 elements. Comparisons needed to combine them into single elements because total 4 are there. If you want to combine them, how many comparisons required here? How many comparisons required? The number of comparisons required is given by formula m plus n minus 1 form. So it is 6 plus 6, 12 minus 1, 11 here. Here 6 plus 1, 6 plus 6 minus 1, that is 11. Again, these fellows are combined. Again, m plus n minus 1, that is 22 minus 1, that is 21. So what should be the total answer? Huh? How? 45, sir? Total is 21 plus 11 or something else? See, elements are 24, sir, but when you are combining, these two, if you are combining into 6, see, that's what 12 minus 1. This number of comparisons is given by m plus n minus 1. That is a formula. Oh, okay. Oh, sorry. Yeah. I understand. Yeah, I understand. Sorry. My mistake. Yeah, so it is, 11 comparisons, 12. Yeah. You are correct. I'm thinking somewhere. Yeah. Correct. So here it is 24 minus 1, that is 23 comparisons required. Of course, total here 24 will be there. Yeah, correct. You are correct. So 23 plus 22, 45 is the answer. You are correct, sir. I'm correct. I taken wrong. Forty-five is the correct answer. See here, first you are having 6 elements. These are combined to form 12 elements. Then these are combined to form 24. These are the number of elements, sir. But the number of comparisons is given by formula m plus n minus 1. That is, here for getting these 12 elements, yeah, even I was thinking differently, right? For number of comparisons required for this is 6 plus 6, 12 minus 1. So the number of comparisons required to get these 12 elements is 11. Number of comparisons required to get these 12 elements is 11. Then again, to get these 24 elements, how many comparisons required? 23 comparisons. Obviously, how many are there? One less than that. So total number of comparisons would be 11 plus 11 plus 23. Is the idea clear? Now is that okay, Babu? This is a regular problem based on a min-max algorithm. All of you know min-max algorithm. See, min-max algorithm is one very interesting question, very regularly they ask. There is something called straight min-max algorithm. With straight min-max algorithm, best case will be n minus 1, but worst case, it will give you 2n minus 2. Okay? Whereas, when you use the recursive min-max algorithm, the best case, always, because it's a recurrence relation, it always gives you the time complexity equal to 3n by 2 minus 2. Very good, sir. So, minimum number of comparisons, obviously, because you can't guarantee best case always. So, in the worst case, what is best? Min-max recursive algorithm is best. That is the answer we are going to take. So, 3n by 2 minus 2, that is 3 into 120 by 2 minus 2, which is 180 minus 2, yani 178. AI around 2011 or 12 I taught last time. AI. After that I haven't gone through that regularly. It's very interesting. AI, machine learning, these concepts are very interesting. Let us brush up sometime, have separate sessions on them once GATE is over. The next one. Consider a sequence of not 14 elements here, sorry, only 8 elements. See, you know what is it called? Maximum subarray subproblem. Maximum subarray subproblem. Maximum subarray sum. Very good. Pranab Paul done it very quickly. Which algorithm you used, Mr. Pranab? Which algorithm you used, Mr. Pranab? Prajwal also give an answer. Which algorithm you used? Very good. So cadence is the best algorithm. Cadence is the best algorithm. Very good. 8 is the answer. So you can take sum or the current sum and final sum. Okay. It takes order n time and you can call it as answer. So we start with -3 here, -3 here. Now, next time when you take the next number -4, here it's like, you know, -4, yeah, -3 plus -4. So obviously -4 is better. So this is ignored. So we starting from here again. Okay. So -4 is what we take. -4 is what we take. Because it is not better than that, we don't update it. Next we get 5. 5, yeah, -4 plus 5. Because this is cancelled here. Either it is 5, yeah, 5 minus 4, 1. Which one is better? 5 is better, so it is ruled out. 5 is better. So your problem starts from here itself. So here it is 5. And this is updated. Because 5 is better, we update this also. Next it is -1. Yeah, 5 minus 1, 4. Which one is better? 4 is better. That is, we continue from here, sir. So 4 is better. 4 is not better here. Next it is 2. Yeah, 4 plus 2. So obviously 6 is better. So 6, and it is better than this, we take it. Then next one is -4. Yeah, 6 minus 4. That is 2. Obviously this is bad. 2 is better. We'll take 2. Next is 6. Yeah, 2 plus 6. That is 8. Which one is better? 8 is better. It is better than this. We take it. Right. Next is -1. -1, yeah, to 8 minus 1, 7. So what is the best value? 8. So this answer, you see this updation happened from here. This updation happens from here. So this is the longest subsequence, my friends. Longest subsequence. 5 minus 1, 2 minus 4, 6 is the longest subarray whose sum is equal to, longest subarray whose sum is equal to 8, my dear friends. So this is the answer. Hope you understand. Some general question about quicksort, Babu. They're all direct questions, so I'll not take much time. In next 10-15 minutes, I think we should wind up this, or otherwise I'll give it as homework for you. And towards the end, I'll just give you all the sorting algorithms, time complexities, and their natures quickly. A quick review of all the sorting algorithms so that this topic will be completed properly. And in the next session, we'll see greedy algorithms. We take up problems on dynamic programming. Then we take up problems on graph algorithms. If any special topic you want, please let me know so that I'll discuss that. Here, even though quicksort works in the worst case both for sorted and reverse sorted. Quicksort works same, worst case for both sorted and reverse sorted arrays. The first array is having 5 elements, whereas second array is having just 4 elements. This is having 5 elements. This is having 4 elements. So this will dominate. Rod cutting, I think recently I discussed that rod cutting problem. If you want, I'll discuss that in, we'll take up one example for that in next session, that is Sunday session, and we'll discuss that problem, sir. Sum of subset problem also, if you want, we'll take up, because not not regularly. Rod cutting is simple problem, sir. Subset sum problem little involved, but it's not like ruled out or difficult like that. You can easily do it. You want? See, please let me know, because accordingly I need to create the PDFs and all. Okay, the PPTs and all. If you want that particular thing, I'll give it, because when people are not interested, why to waste your energy and my energy there? No, rod cutting is not lengthy. Rod cutting is simple. Subset sum, it's not lengthy. Let us see. We will take a simple problem and complete that, so that we'll get the idea of that. Yeah, surely. I'll take up both the problems then. Hope you understand this answer. You understand? Because it is having 5 elements and it is having 4 elements. Obviously, it will take more time. Hope you understand. Please, dear, see, when you want more sessions, it has to be shared, subscribed, liked by many people. Then what happens? We'll get more motivation to come up with more sessions. Okay? Yeah, Sunday morning I'm coming up with that session. So what we suggest is, please like, share, subscribe. See that it will reach more number of people, so that we can discuss more. Right? You have an array of n elements. This is a very interesting problem. Suppose you have implemented quicksort by always. All of you understood this problem, previous one. Anyone having issue? Anyone having issue? Anyone having issue with this? Recursion tree method. Recursion tree method. Which tree method you are asking? See, generally, the recursion tree method we may not utilize, sir, because even in the recursion tree, the what you call the branches which are of lower order terms, they will be ignored. Ultimately, it is kind of iterative method. Yes, sir. Okay. Next one. Yeah, please answer the question, sir. Please answer the question. See, graph is a very vast topic, my dear friends. See, I thought of coming with a full session on graphs actually. The problem with graphs is, if you want to understand graph problems, you need to solve some questions on that. But mostly, MSTs and all people readily answer that. But after that, they'll not think about the small variance which can be done. Yeah, we'll try to cover up some shortest path algorithm like Dijkstra's algorithm, Bellman-Ford's algorithm. Okay. See, it's like, this is marathon series. In this, I can only come up with this session, my dear friends. Because earlier I asked this, like, please let me know what topics you are interested, so that I can come up with those topics also. Any specific topic, suppose, maybe after marathon series, if you want any particular specific topic in more detail, you please mention here or in my Telegram group. Hopefully, you all know my Telegram group, CS_Sridhar. You can join my Telegram group, where you can send me. See, it's not like, every topic can be discussed, my dear friends. Very important. Okay. Now, if you ask some, knowledgeable concepts that may not be discussed now, my dear friend. That is not useful for examination. Okay. Yeah, DFS, BFS, maybe in data structures part, we'll try to see, sir. I'll try to cover under data structures part. Okay. See, now please answer this question, Babu. We are getting into different story. What about the answer for this? Yeah, DFS, BFS, I'll take it. Either here or in data structures, I'll take it. For sure. Order ends. See, actually, in this, surprisingly, what he says, suppose you implement quicksort always by choosing central element. See, he is very tricky question it is. He's saying central element. Central element need not be mid element, my dear friends. Central element means in the given array, central element. That may not be central element, may be the least element. Then it will go to the left side and you get the worst case complexity, my dear friends. So the complexity here is order n squared. The next problem. The next problem. Okay, my dear friends, next problem. B. See here, median of n elements can be found in order and time. We have this median of medians algorithm, which can find median in order and time, my dear friends. Suppose you find median in order and times, every time you find median and that is selected as pivot, then you are using the quicksort algorithm to place that element at that particular position. Obviously, you are going to get the best complexity, t 2n by 2 plus theta n. Because the median of median algorithm takes theta n time, my dear friends. Yeah. So the complexity for this would be theta n log n, my dear friends. Theta n log n, my dear friends. This is a very interesting question. Suppose in quicksort for sorting n elements, the n by 4th smallest element is selected as pivot using an order n time algorithm. What is the worst case time complexity of the quicksort? That is, we have a method which can find n by 4th smallest. Previous problem you are able to find mid element. Suppose you have an algorithm which can find n by 4th smallest element in order n time, then also we can get the best case of the quicksort, my dear friends. Best case of the quicksort, my dear friends. Okay. So these are all straightforward questions, my dear friends. Please answer this. And this is for you, my dear friends. Please answer this so that we'll complete today's session here. We'll complete today's session here. What is the answer for this problem? Next problem. See, assume that last element of the set is used as partition element in quicksort. Last element is selected. In which of the following cases worst case complexity of quicksort occurs? See, my dear friends. The elements are same, or the elements are reverse sorted, or elements are sorted. See, in all the three cases, quicksort works in worst case, my dear friends. Yeah, reverse sorted means descending. In all the cases, quicksort works in the worst case when you take pivot element as first element, yeah, the last element, sir. In such cases, what happens? ABC will give you the worst case complexity. See, the last one, the elements are multiples of 5. See, elements are multiples of 5, but they are not sorted. Nothing is mentioned now. Suppose if they are sorted, then it may not. See, here we can't say that, but these definitely it will perform in worst case, my dear friends. See, this statement may be changed like element is selected randomly. Like that they may mention, my dear friends. Please note that, my dear friends. Okay. So, my dear friends, this Tables will be provided to you, the sorting methods and their properties. I want all of you to go through it, sir. Once again, all the properties are mentioned here. Okay. So what I'm doing is, it's a time for some advertisement. So there is some general aptitude. Yeah, PDF mil jayega. General aptitude by Rakesh Talreja sir, coming soon. 15 marks in 15 hours for GATE 2023. So you can join that particular session and join this session which is conducted by both Rakesh Talreja sir and Ankit Joshi sir. Nothing is I am possible. Non-stop mathematical marathon complete syllabus in 2 days coming soon. Adaptive means it adapts to the nature. Means it is already sorted, means when it is already sorted, you will get the answer faster. Already sorted list, you will get the answer faster. So insertion sort is adaptive. And we have this test series, my dear friends. You can take this particular test series, my dear friends. And these test series are having all these particular details, like you are having 60 plus tests covering GATE and ESE, detailed mock analysis. Virtual scientific calculator is provided, as you can practice. Chalega. Curated by GATE experts, and all India open mock tests are there, and around 4,000 plus practice questions from that these test series were conducted. Okay, so this is about this, my dear friends. Yeah, now you please tell me what is your doubt, Babu. I am here back once again. Yeah, please tell me. I am back. Please let me know. These are the time complexities for different important sorting algorithms and their properties. Where is it? Answer. Right? Adaptive means what, sir? Adaptive means when it is already sorted, it speeds up. Its complexity will be fast. Means it speeds up. Means sorting will be done faster. For example, you see insertion sort is adaptive. Bubble sort also adaptive, my friends. Of course, one version of bubble sort is not adaptive, but you can make small modification in the code so that even bubble sort can be made adaptive. But the other sorting algorithms are not adaptive. Unplaced. What is unplaced, Babu? Saubhigya? What is that unplaced? Nana? Today's password. Yeah, today's password. Very good. Today's password will make it from some solution. Solution of this problem. I like the solution of this problem. Algo 45. We already given. Algo marathon. Algo M 45. It looks like a medical term. No. Pranab. See, adaptive in the sense, when it is already sorted, it should speed up. In that sense, they'll say, don't write Satya there. I'll change the password then. Okay, we'll change the password. Password valid only for 1 day. Like that, we can put that. Right? Anyhow. So that is the idea, my dear friends. You can remove that comment, my dear friends. In place means the additional storage requirement is constant. Additional storage requirement is constant, my dear friends. See, actually, merge sort and quick sort, they are not in place. Am I clear? Merge sort require additional storage. See, quick sort is taken as in place because that recursion stack space is not considered. Recursion stack space is not considered, my dear friends. Recursion stack space is not considered, my dear friends. Okay? Clear to you all? Yeah. Yeah. So we are stopping here, sir. Thank you. We'll meet on Sunday morning 10 a.m. for our next session. That's all for today, Babu. Have a great time. Any doubts you can ask me, otherwise we'll call it a day. Thank you very much, sir. Eight likes from your side. See, things are little hectic, sir. Once things get settled, can plan things differently, sir.